Carrying on with our overly simplified model of the entire universe, where everything is broken into matter and energy, that means that human civilization must also require inputs of matter and energy. The energy that we get raw from nature in its various forms, we are going to refer to as primary energy. So we need primary energy. And by way of parallel construction, we'll call the matter that we need to get from the Earth, we're going to call that primary matter, or we'll just call it raw materials. And these are the inputs for civilization. Once again, grossly oversimplifying everything is a way of sort of showing a nice parallel model, and then what we have coming out of there is going to wind up being waste energy. And waste matter, or waste material. And of course, in addition to that, we have everything that builds civilization. So everything that we use goes into civilization, and then once we're done with it, we exude some waste energy, we exude some waste material. Broadly speaking, what we're going to be focusing on in this video is this stuff right here, the primary energy that we are getting from nature. This primary energy use is growing faster. In fact, it is growing faster than human population is. This primary energy use is also coming from a finite number of sources, and those finite number of sources can be categorized, and that's what this video is going to do, is it's going to break these primary energy types into different categories, which we'll then explore in later videos. We're going to break all of our primary energy, the energy that we get from nature, into two categories. And I'm going to do that, and then I'm going to talk about how each of these categories has some things in common that make it make sense that we're going to break them into these two categories. The most basic of all is going to be food. Food is very similar, both in structure and in origin, to things we call biofuels. Biofuels are recently dead things like trees and so forth. Now, in addition to food and biofuels, what we're going to have is we're also going to have dead stuff that died a long time ago, which we will call fossil fuels. And this includes coal, oil, and natural gas. So we have food, we have fossil fuels, and then we have nuclear fuels. Over here, what we're going to have is things that are fundamentally different. So we've got wind as one source of energy. Another source of energy would be sunlight. And we can also harness energy from water in its various forms. And this is going to include things like hydropower, tidal power, wave power, and even, oddly, most forms of geothermal. Try to think for yourself, what's similar about these? What's similar about these? What I've come up with in my own head is that every single one of these is a fuel of some sort. And every single one of these involves energy flowing. So I'm going to call this flows. So we have our fuels and our flows. When we look at this, what we can say is that this is matter that gets transformed and when that matter gets transformed, energy comes out. Oh, and there's also waste matter. Okay. So that transformation consumes the fuel. Now, that's interesting, and it's also interesting to note that this process means that our matter is energy dense. There's an awful lot of energy in a small volume or with a small amount of mass. Flows, on the other hand, no matter transforms. So if we start with wind, we're going to end with air. So we're starting with air that's moving, we're ending with air that's moving less. We're starting with sunlight, which is an electromagnetic wave. We're going to end with a different sort of electromagnetic signal. With water, we're starting with hydro. So there's no real, with sunlight, there's no real matter coming in. We'll talk more about that later. But electromagnetic signal comes in, electromagnetic signal comes out. With the water, hydropower starts with water, it ends with water. Same with tidal, wave, and even with geothermal, you start with hot steam underground and get less hot steam underground. So the matter is not transforming. We're ending with the same matter that we start with, and there's still energy out and waste matter. But because we're not transforming our matter, the matter is not consumed. And because they're not consumed, these are renewable. This renewability functionally means that the wind can get energy again, the sun will shine tomorrow, and this water can get more energy to it. The downside, though, is that they tend to be energy diffuse. So it takes an awful lot of land to make a solar farm work to get the same amount of power as to get, say, a coal-fired power plant, just to try to compare apples to apples. So, consumed, not consumed, energy dense, not energy dense. Human society requires energy inputs, primary energy, energy that we get from nature. Nature has a selection, but a limited selection of where we can get that energy from. We can get them from fuels, and we can get them from flows. And as you can see in the chart, where the blue is the fuels and the red is the flows, what humans have been getting energy from is fuels. What humans will probably continue to get energy from for the foreseeable future is also fuels. In fact, today, more than 90% of the energy that humans wind up getting from nature is coming from some sort of fuel. In the next couple of videos, we will explore more about fuels and flows. But in the series coming, over the next quite a few videos, we will explore every single one of these fuels and flows, both their positive aspects and their negative aspects, in detail.